Mrs. Gale, what are you doing?
Bit of Tai Chi.
Why are you doing Tai Chi?
Because I did it every day with my class.
Is it helping?
Yeah, it is helping.
All right, well, let's crack on with the lesson then. Come on, move yourself.
I think what's not helping is your voice.
Oh my God. Rude. Right, hello, boys and girls. It's Miss Mia and Mrs. Gale. We are back.
With a vengeance.
Way!
Wing.
We are going to start with some maths today, so Mrs. Gale, take it away.
Okay, so just a quick recap here of various arithmetic parts. Questions not in order, don't mind how you answer them, and there's an extension here. I'm not going to model too much of this, a lot of it is just revision. So pause the video at this point and have a go at these questions.
Just going to move the phone so you can see the questions. Oh. There you go. So pause the video here and then have a go at these questions. And as if by magic, we are back. Right, Mrs. Gale, do you have any answers?
Yep, I'm pretty much going to get you to self-assess these. So down the side here.
Do you want to read them out?
Question numbers. So because they weren't in an order, it starts from question 7 here because it's taken from an arithmetic paper. Just have a look here. Oh, too far. Question 7 was 463. Question 8 was 2.55. Question 9 was 140. Question 10 was 3/5. You could also have equivalent fractions for that.
Can you give me an example?
Yeah, 6/10.
Oh, nice work.
11, 70 and 12, 128. These questions here, square number and a prime number that added together gave you 22 would be 9 would be your square, 13 would be your prime to give you that 22. The other numbers whose factors were 12 was 6 and calculate the width of one shaded rectangle, it was 7.
I'm not going to ask you to model this question now.
It's quite tough, that one.
It is quite tough.
Okay, when we're ready, Miss Mia. 3, 2, 1. LO.
To use the formulas for calculating the area of a square, rectangle, parallelogram, and triangle.
Woohoo!
Right.
So, before we go anything, we just need to recap here, what is the area of something? So what do I mean by calculating the area of a shape? Just pause the video, have a quick chat with the person nearest to you, whoever that may be. What is the area? So, the area is for following. It is a measure of how much space there is on a flat surface. It's really important at this note to notice that it's a flat surface, not a 3D shape, so it's always a 2D shape here. So here, for example, I wanted to know what the area of this rectangle would be. I know that I'm asking the space inside of this rectangle is what I'm measuring. How much space is there? The same for the triangle, the space inside of it.
I think we get it, Mrs. Gale. Let's move on.
I'm carrying on. And the space of the square. I'm sure you really appreciated that. Thanks, Miss Mia.
No worries.
So, Miss Mia, do you want to just read the title of the next one?
Yep. So it says area of a rectangle and a square. So we're just going to look at the formula.
Okay.
Right. So area of a square and area of a rectangle is exactly the same. Mrs. Gale, follow my lead. It's base times height. Say with me. 3, 2, 1. Base times height.
Have a go at home. Go on. You know you want to. Right, okay, so it's really important that you memorise them. Maybe jot that formula down, because at the end of the session, I'm going to ask you to memorise what were those key formulas from the lesson. So jot that down and have it to hand. Okay, so now what we want to do is we want you to apply the skill, okay? So to calculate the area of any square or rectangle, you must use that formula that we practice, which was base times height. Okay, it's really important you memorise that. So let's have a look at this question here. And you can see here we've got a square. We've been given the 2 dimensions, which are 30 centimetres and 30 centimetres.
Would we need both of the dimensions, Mrs. Gale, for the square?
We do. Well, do you know what? You don't have to have the both dimensions because they're exactly the same.
That's what I was getting at.
There we go. So what that would mean to calculate the area, I'm going to do base, which is 30, times the height, which would be 30. Okay. Now, lots of you I know will take off a 0 to do 3 times 3, which is 9, and then add the zeros back on.
It's not mathematically accurate, though, is it, Mrs.
It's not, but you need to understand that you're moving the placeholders, okay? So 30 times 30, your final answer would be 900. Now, it's important to recognise at this point your units of measurement are going to be centimetres squared. And the reason why the squared is in that little 2 is actually, that means that if I had a square that was accurately drawn by 30 centimetres by 30 centimetres, I could get 900 little squares in there. That's why it's centimetres squared. Okay, so we're now going to look at area of a rectangle. So we've got a rectangle here with the dimensions of 16 centimetres and 12 centimetres. Miss Mia, why are those dimensions different to that of a square?
Well, Mrs. Gale, I'm glad you asked. So a square is a regular polygon, and thank you, and all the dimensions are exactly the same, whereas a rectangle, the length and the height will differ. So that's why you have two different dimensions.
That's
very succinct.
Very, very good explanation. Well done, Miss Mia.
Thank you.
So, with this part here, have a think about the formula for area of a rectangle, which is, can you remember?
Base times height.
So, our base would be exactly the same as the one above it here, which would be 16. Our height would be 12, so I'm going to do 16 times 12. Now, Miss Mia has got a really good mental maths way of doing this. You can use long multiplication, but actually, you can do some mental maths here. So, Miss Mia, what was your strategy?
I'm on fire today. So, you may recognise that the 16 is made up of 10 and 6. So, what you could do 10 times 12, which is 120. And then you can do 6 times 12, which is 72. And then you can add them together, and that will give you 192. Equally, you could do 16 times 10, and then 16 times 2, or you could use your long multiplication method. Now, is that our final answer, Mrs.
Yes,
Hill?
that is our final answer. Because actually,
sure?
if we did it the other way, which Miss Mia said, and we could use long multiplication to check, but actually this is a really good mental math strategy, and it's pretty quick actually, to be honest, rather than writing out a whole long multiplication. So Miss Mia said the other way. So what you could do, like she said, you could do 16 times by 10, because what I've done here is I partitioned the 12 into 10 and 2. 16 times 10, which gives you 160. And then you would do 16 times the 2 here, which I know that double 16 is 32. I add those two together, which is going to give me 192. So actually it's a different way of checking it, and that's accurate. So that's not our final answer there, because we need to have our units of measurement.
Way.
So it's 192, because our units here are centimetres, it's centimetres squared. Okay,
Cool.
so if you need to have another practice of that, have another look back. But what I'm going to ask you to do now is, on your sheets of paper at home, is have a go at calculating these blue rectangles. Now just be aware here, the purple rectangles are going to be your answers. So just have a look at the blue rectangles.
What about the squares?
And the squares here as well. Have a go of those.
So I'm just going to bring it forward, so a bit closer so you can see. Please pause the video, take your time, make sure that your calculations are accurate, especially with questions 3 to 6. And then we'll reveal the answers in the next few seconds. As if by magic, we are back.
Don't know. Okay. Right. Okay, here we go. So 20 by 20, the area of the square for number 1, your answer would be 400 centimetres squared. Number 2, your answer would be 1,600 centimetres squared. Number 3, your answer would be 216 centimetres squared.
I'm going to press it. Number 4 would be 864 centimetres squared.
Go on, Miss Mia.
Number 5 would be 351 centimetres squared, and number 6 will be 1,053 centimetres squared. I must say this now, boys and girls, if there is a mistake, not my fault. Mrs. Gale loves making marvellous mistakes, so if you do find one, just get a calculator and check it. I'm sure it's all accurate. What did you say, Mrs. Gale?
Yeah, hopefully. Right, let's move on. Okay, so just recap here. Have a think. What was that formula for area of a rectangle and a square? Don't say it just yet. Just have a think and see if you can memorise that. Okay.
Okay.
Go. So when we look at area of a parallelogram, we know that it is
Base times perpendicular height. Now, why are we doing this with our hands, Mrs. Gale? What does perpendicular mean?
Perpendicular is the same as a right angle. So if I've got Miss Mia's hands here, the perpendicular side is this right angle here. So this would be your 90-degree angle. So it's really important that you understand that perpendicular height, because it's not a slanted height. And actually, that's why we've got here this parallelogram. So if we look at this parallelogram here, we've got our base, which is 8 centimetres. Now, the perpendicular height is where that height, or sometimes referred to as the vertical height, goes straight up. And that vertical height is 2 centimetres. So what I need to do here is I need to do 8 multiplied by 2, which gives me an area for this parallelogram of 16 centimetres squared.
Good work, Mrs. Gale.
Thank you. Now, it becomes a bit different here when the perpendicular height is just to the side of the parallelogram, so don't be put off by that. Here we've got our base, and this base here, the 6 millimetres, is just this part here. Gosh, this is a small parallelogram for 6 millimetres.
Do you mean it's a big parallelogram for 6 millimeters?
No. Well, yes, but I'm just imagining the real life one, it would be tiny.
Okay.
And our vertical height here comes up the side here. And the reason why it's dotted is because this part isn't part of the parallelogram. They're just telling you what the height is from the base to the top, which is 5 millimeters. So what I need to do, base 6 multiplied by 5, oh, some interesting colours going on here, is gives me 30 millimeters squared because it's area still. So those are your how to calculate the area of a parallelogram. What I want you to do is pens at the ready, have a go, pause the video, give yourself 5-6 minutes, calculate these areas of the parallelogram. I must say at this point here though, be careful because the units of measurement have changed. IN stands for inches, YD stands for yards, so just be careful of that when you put your final answers. Okay.
Okay, and as if by magic, we are back, aren't we, Mrs. Gale?
Raring.
Okay.
Okay, so
My hand gets in the way a lot.
I know. Right, number 1, your final answer was 22 centimetres squared. Number 2 was 90 inches squared. Number 3 was 425 inches squared.
Number 4, 319 yards squared. Interesting. And number 5, we had 2 decimal numbers, so 190.71 inches squared. Okay, cool. Let's move on.
So, before we move on to the next part here,
You've got a bit jazzy, haven't you,
you've
Mrs.
got a little
Gale?
bit jazzy. So I've got a bit of like some sort of cutting parts here to prove it. So why is the formula to calculate the area of a rectangle the same as the parallelogram? So ultimately it is base times height. We know that in a parallelogram it is vertical height, but actually in a rectangle, if we go back here, a rectangle will always be a vertical height. It will always be a perpendicular height.
Oh, nice.
So it is absolutely the same. And this is why you can prove it and say why it is the same. So you're going to need these things to get ready. So go and get a pair of scissors, a ruler, a pencil, and something to kind of draw a rectangle on and cut it out. So I'm going to ask you, as you watch this video, what I want you to do is there'll be 2 different shapes here. There'll be a rectangle, which is an orange one, and then there'll be a parallelogram, which is a green one. I just want you to have a go at drawing out the orange rectangle. It doesn't need to be a particular size. You don't have to have it a particular size, but you could just make it easy for yourself and do a 10 centimetres by 6 centimetres rectangle. That'll be much easier. And you must draw it to size, to scale, because otherwise this is not going to work.
And it'd be a nightmare.
So, make sure you get those things, scissors, ruler, pencil, and have the template of a rectangle cut out and ready to go.
I think you already had it up, Mrs. Gale, so let's just see. Here you go, all raring to go.
Okay.
Oh, right at the end.
Too far.
Too far. Right, enjoy, boys and girls. What an interesting video, Mrs. Gale. Oh, we don't want to watch it again. It wasn't that interesting. Right, let's carry on.
Okay, so just pause at this point here and just tell me or say out loud what is the formula for area of a rectangle and a square, and what is the formula for area of a parallelogram?
Those eyes are so straight.
I know, super strict. Look like my mum. Right, okay. Next part. So, areas of a triangle. You can write this in either way. So, area of a triangle is half the base times the height, or
I prefer this method.
it can be written as this. You do base times height. That line there means divided by 2.
But surely there has to be an action for this.
Yes.
Ready?
Base times height divided by 2. Oh wow, we were so
We actually
safe there.
rehearsed that. That's good.
Right, okay, so what does this mean? How's this going to work? So we've got two triangles here.
Do you know what kind of triangles?
I was just going to look at that. We've got a right angle triangle here, and we've got an isosceles triangle here.
What's an isosceles, Mrs. Go?
An isosceles triangle is a triangle that has got two angles and two lengths that are the same, and one of them is different. So in this case here are the two angles that are the same, here is the angle that's different, here are the lengths that are the same, here is the length that is different.
And this would also be known as a scalene triangle because all lengths and angles are completely different.
You can also get an isosceles right angle as well, Miss Mayor. Did you know that?
No, I didn't.
You can. I found that out the other day. Right, anyway, we're deterring. So let's go back to the formula for areas of a triangle, which we know is, this one's an easy one to use, base times height divided by 2. So what that would look like is base times height, and then I'm going to divide it by answer by 2. Okay, so what does that mean? It means that 6, here's my base, times this vertical height here. Now some of you will look at this diagonal line here, and it's really important that you don't use that. That's the hypotenuse. So you don't use the hypotenuse when you're calculating the area of a triangle. It's the 4. So 4 divided by 2. Okay? So here, I know that 6 times 4 gives me 24, and 24 divided by 2, which is the same as a half of 24, gives me 12. So my final answer is 12 centimetres squared. So just recap that again. I did 6 times 4, which is the base times the height. I must do that first 24, and then my final answer, I divide it by 2, I half it to give me 12. I don't add these two together. That's my final answer. Okay, thanks, Miss Mia. Miss Mia, have a go at that one next to you.
All right, so here we can see that the base is 5 metres and the height is 8 metres. So I'm just looking at the formula. So base times height and then divided by 2. So I know I have to do 5 multiplied by 8, which is 40. And then my next part would be 40 divided by 2. Well, that's the same as half of 40, which equals 20. So my final answer would be 20 centimetres squared. Are you proud, Mrs. Go?
I'm very proud, Miss Mia. You did a great job.
Thanks.
No worries. So the next part here is what I want you to have a go at, is on your pieces of paper at home. I'd like you to have a go at calculating the areas for these triangles. Now again, I've changed the units in some of them. There's inches here at the end. So make sure you use the base times the height divided by 2. Pause the video and have a go.
There you go. There you go. Okay, and as if by magic, we are back, aren't we, Mrs. Go?
We are back raring to go. So here we go with our answers. Number 1, your area was 21 centimetres squared. Number 2, your area was 40 centimetres squared.
Number 3, I don't know why you always pass me the pen, because I don't like the pen.
Sorry.
132 centimetres squared. And number 4, 112 inches squared. Okay, good work.
Now, I want you to recap on everything that we've learnt now.
Hopefully you're listening.
Okay, so at the beginning of the session, I asked you to maybe jot down the formulas as we went through. Don't worry if you haven't done and you've forgotten them. Let's see what you can remember. So, turn your pieces of paper over, and can you write down the names, square, rectangle, triangle, parallelogram, or you could just do it rough freehand, you could draw each shape. Can you write next to it, what is the formula for calculating the area for each one of those shapes? Off you go.
And we're back. Right, so Mrs. Gale, should we go through the formulas really quickly?
Yep, go on
so
then, Miss
for square and rectangle, we know it's exactly the same. So we know it's base times height. Okay? For the triangle, you did it in a random order. For the triangle, we've just had a look at the triangle. So it's base times height divided by 2. And we divide it by 2 because if you put two triangles together, it creates a rectangle.
And if we had a look here, Miss Mia's absolutely right. Let's have a look here at a line, and let's have a staggered look here. If I drew a line here across this rectangle here, you can see there's two triangles that make it onto that rectangle. That's why you have to divide it by 2.
Okay. And then parallelogram, it is base times the perpendicular height.
It's really important that you have that perpendicular height, okay, base times height. So hopefully that's been useful. You'll need to memorise them because you'll need them for year 7 and beyond.
And all the learning from today will be on the school website. So please go on the school website. We've got lots of different worksheets for areas of triangle, squares and rectangles and so on. So do enjoy, and if you need to go back in the video, recap the knowledge, and stay safe. See you later. Bye.